Radar. It's a word that conjures up images of spinning antennas and blips on a screen. But what exactly is radar? Simply put, radar is like a powerful echolocation system. Bats use sound waves to navigate and find food. Radar, on the other hand, uses radio waves to detect objects and determine their location, speed, and even shape. Radar plays a crucial role in various fields today. From air traffic control, keeping our skies safe, to weather forecasting, helping us prepare for storms, radar is everywhere. Ships use it to navigate through fog, and meteorologists use it to track storms. Radar is even used in speed guns by law enforcement to keep our roads safe. It's a technology that has become essential to our modern world. So how does radar work? Imagine you're shouting in a canyon. Your voice travels as sound waves, hits the canyon walls, and bounces back to you as an echo. Radar operates on a similar principle, but instead of sound waves, it uses radio waves. The radar system sends out a pulse of radio waves. When these waves hit an object like an airplane or a raindrop, they are reflected back towards the radar. The radar system then receives these reflected waves, or echoes. By measuring the time it takes for the radio waves to travel to the object and back, the radar can calculate the distance to the object. The strength of the reflected waves can tell us about the size and shape of the object. And by analyzing the changes in the frequency of the reflected waves, radar can even determine the speed and direction of a moving object, like that airplane heading towards the airport. Now let's take a peek inside the radar system and understand its different parts using a block diagram. Think of a block diagram as a simple blueprint. It shows us the major components of a system and how they connect. First, we have the transmitter. The transmitter generates the radio waves that the radar will use. It's like the powerhouse of the system. Then there's the antenna. The antenna acts like a messenger, sending out the radio waves from the transmitter and receiving the echoes reflected back from objects. Next up is the receiver. The receiver is like our ears, capturing the faint echoes of the radio waves. It amplifies these weak signals so that they can be processed. Finally, we have the signal processor. This is the brains of the operation. The signal processor analyzes the received echoes, removing any noise or interference, and calculates the distance, speed, and direction of the objects. The processed information is then displayed on a screen for us to see. Radar's ability to see in the dark, through fog, and even rain makes it incredibly versatile. Today, radar technology is not just limited to aviation and weather forecasting. It's being used in innovative ways in various fields. Self-driving cars, for instance, use radar sensors to detect obstacles and navigate their surroundings. In healthcare, radar is being used to monitor patients' vital signs without any physical contact. Archaeologists use ground-penetrating radar to discover hidden artifacts and map ancient structures without digging. And that's not all. As technology advances, we can expect to see even more exciting applications of radar in the future. From space exploration to environmental monitoring, radar technology continues to shape our world in remarkable ways. It's a testament to human ingenuity and our quest to understand and interact with the world around us.